Have you ever wondered why Venus, though further from the Sun, is hotter than Mercury? It's a fascinating question that has puzzled scientists and space enthusiasts alike. You see, in the grand cosmic ballet of our solar system, Venus and Mercury are our closest neighbors, dancing in orbits that are nearer to the Sun than our own. Mercury, the innermost planet, is a mere 36 million miles away from our star. Its close proximity means it's perpetually bathed in the Sun's intense heat, with surface temperatures that can reach a blistering 800 degrees Fahrenheit during the day. Yet when night falls on this tiny sun-scorched world, temperatures can plummet to a frigid minus 290 degrees Fahrenheit. Quite the dramatic drop, wouldn't you agree? Now, let's turn our gaze to Venus, the second planet from the Sun. Despite being an additional 26 million miles further out, Venus boasts an average surface temperature that's even higher than Mercury's daytime high, clocking in at a sweltering 864 degrees Fahrenheit. That's hot enough to melt lead. So how does Venus, sitting pretty at a distance of 67 million miles from the Sun, manage to outsizzle Mercury? Is it flaunting the laws of physics, or is there something more at play here? Well, my fellow cosmic explorers, the answer lies not in distance, but in atmosphere. Yes, the blanket of gases that wraps around a planet plays a vital role in regulating its temperature. It's this atmospheric factor that makes Venus the hottest planet in our solar system, despite its further distance from the Sun. To unravel this mystery, we must first understand the role of the atmosphere in controlling a planet's temperature. This is where our journey into the intriguing world of planetary science begins. So, buckle up and prepare for an adventure that's out of this world. Think about wearing a coat on a cold day. The coat keeps you warm, right? The atmosphere does the same for a planet. Just like your winter coat, the atmosphere serves as a protective layer that traps heat, keeping the planet cozy and warm. Now you might wonder, how exactly does this happen? Well, it's a fascinating process called the greenhouse effect. Imagine the Sun as a huge heater. The Sun sends out light and heat, which we call solar energy. This solar energy travels millions of miles across the vacuum of space until it reaches our planet. Some of this energy is reflected back into space, but a good amount of it is absorbed by the Earth's surface. This energy warms up the ground, which in turn radiates heat back into the atmosphere. Now here's where our atmospheric coat comes into play. Certain gases in the atmosphere, like carbon dioxide and methane, are like the fluffy lining of your coat. They trap some of this outgoing heat and prevent it from escaping into space. This process is what we call the greenhouse effect. It's like a giant, invisible blanket wrapped around our planet, keeping us warm even when the sun goes down. But just like wearing too many layers on a hot day can make you uncomfortably warm, too much greenhouse effect can turn a planet into a sweltering hothouse. The key is balance. The right amount of greenhouse gases in the atmosphere keeps a planet's temperature just right. Not too hot, not too cold. This concept of the greenhouse effect isn't confined to Earth. It's a universal principle that applies to all planets with an atmosphere. Whether it's the dense carbon dioxide-rich atmosphere of Venus or the thin, almost non-existent atmosphere of Mercury, the greenhouse effect plays a critical role in determining a planet's temperature. Now that we understand this, let's delve into the atmospheres of Venus and Mercury. Imagine Venus's atmosphere as a thick, heavy winter coat. It's made mostly of carbon dioxide, a powerful heat trapper. Now let's delve into the details. Venus, our neighboring planet, is swathed in an atmosphere that is around 96% carbon dioxide. Carbon dioxide is a greenhouse gas, which means it excels at absorbing heat. Picture it as a dense blanket, enveloping the planet and holding in the warmth of the sun. The remaining 4% of Venus's atmosphere is mostly nitrogen, with trace amounts of sulfur dioxide, argon, water vapor, and other gases. Among these, sulfur dioxide is particularly interesting because when it combines with water vapor, it forms sulfuric acid, a compound that contributes to Venus's unfriendly conditions. Let's not forget about the pressure. The atmospheric pressure on Venus is about 92 times greater than Earth's. That's similar to the pressure you'd experience about half a mile under the ocean on Earth. This intense pressure further compresses the atmosphere, adding to the greenhouse effect and ramping up the temperature. Now, what about the clouds of Venus? They are not your typical fluffy white clouds we see here on Earth. Venus's clouds are made of sulfuric acid and they're incredibly thick. These clouds reflect about 75% of the sunlight that reaches Venus back into space. But the sunlight that does get through is absorbed by the surface and re-emitted as heat. This heat gets trapped by the dense carbon dioxide atmosphere, causing temperatures to soar. So, in essence, Venus's atmosphere is like a super-efficient heat trapper. The combination of a high concentration of carbon dioxide, intense pressure, and sulfuric acid clouds all contribute to create a scorching, inferno-like environment. Venus's thick atmosphere traps a lot of heat, keeping the planet incredibly hot. But what about Mercury? Mercury, on the other hand, is like a person without a coat in the middle of winter. An apt comparison, don't you think? This tiny planet, the closest to our sun, is surprisingly not the hottest in our solar system. And this conundrum is largely due to its lack of a substantial atmosphere. Think about what happens when you leave a metal spoon out in the sun. It gets hot, right? But once you take it out of the sunlight, it cools down quickly. This is exactly what happens on Mercury. Without a thick atmosphere to act as a blanket, the planet can't hold on to the heat from the sun. Atmosphere, or rather the lack thereof, is a key player in the story of Mercury's temperature. Mercury's atmosphere is so thin it's practically non-existent, comprised of only a few stray atoms here and there. This is known as an exosphere, the term for an atmosphere that is so thin its atoms rarely collide with one another. The absence of a substantial atmosphere means Mercury is exposed directly to the sun's intense heat during the day. But without an atmospheric blanket to trap the warmth, the planet rapidly loses this heat back into space once the sun sets. This results in an extreme temperature swing, from scorching hot during the day to bitterly cold at night. In fact, the temperature difference between Mercury's day side and night side is one of the most extreme in our solar system, ranging from around 800 degrees Fahrenheit in daylight to minus 290 degrees Fahrenheit at night. Quite the difference, wouldn't you say? But why is Mercury's atmosphere so thin? The answer lies in its small size and low gravity, which are not strong enough to hold onto a thicker atmosphere. Over time, any atmosphere Mercury might have had has been stripped away by solar winds and lost to space. So, in the cosmic game of hide-and-seek with the sun's heat, Mercury is at a distinct disadvantage. Without an atmosphere to trap heat, Mercury can't hold on to the sun's warmth. So, why is Venus hotter than Mercury? It's all about the coat, or rather, the atmosphere. Let's take a trip back and run through the key points we've covered. Picture Venus swathed in its thick, heavy atmosphere. This atmosphere acts like a giant, snug blanket, enveloping the planet and keeping it toasty. It's composed mainly of carbon dioxide, a potent greenhouse gas which traps heat and stops it from escaping back into space. This is what we call the greenhouse effect, and Venus's greenhouse effect is an overdrive. The heat has nowhere to go but to bounce around the planet, causing the surface temperature to skyrocket. Now let's contrast that with Mercury. The closest planet to the sun, one might expect it to be the hottest. But Mercury doesn't have a coat, it's practically naked. Its atmosphere is so thin it's almost non-existent. This means that although it's closer to the sun and gets more solar heat, it can't retain that warmth. When the sun sets on Mercury, the heat dissipifies quickly into space. The lack of atmosphere means Mercury is at the mercy of space's chill, causing wild temperature fluctuations between its day and night. So it's not just about proximity to the sun, it's about what you're wearing, your atmospheric coat. Venus's thick, heat-trapping atmosphere keeps it hotter than Mercury, despite being further away from the sun. It's an example of how the unique characteristics of a planet, not just its location, can drastically influence its climate and temperature. In the grand cosmic ballet, Mercury and Venus dance to their own tunes, guided by their distinct atmospheres. These two planets remind us that there's more to a planet's temperature than just its distance from the sun. It's the delicate interplay of multiple factors, with the atmosphere playing a crucial role. So, The next time you put on a coat to stay warm, think about how Venus uses its atmosphere to do the same thing.